Okay, hi there, welcome back. Hopefully you've watched all of the YouTube videos now, all of those lecture notes videos. And so now we're ready for me to explain exactly what your submission for this Homework 7 assignment is going to look like. If you recall in the YouTube videos, there were two particular moments when I stopped the videos so that I could train a model for a couple of hours. And you're going to do that as well at those same two locations. In particular, you're going to train two models, one where you're using this conditional model flag, and then one where you're not using this flag. So when I did this, in those lecture note videos, I used the SGD optimizer with a GRU recurrent neural network. I want you to use some different combination of things than what I used in the videos. So you could use, for example, an LSTM with Atom, or you could use just a plain recursive neural network with something like AdaGrad. But you cannot use a GRU network, and you cannot use stochastic gradient descent. And so the reason for this is I just want you to get more practice going through the procedure of how do you find good hyperparameters. And so I don't want you to just pick the hyperparameters that I used in that video. Here's the specific requirements that you need to have on your loss and your training accuracy. And in my videos, I got much better results than this, and it only took me, I think it was about like 2 hours for each of those training sessions on my laptop. My laptop's about 8 years old now, so I think you should all be able to achieve better numbers than these by far. Yeah, so like my accuracy was around like 95%. Okay, so that's sort of like the main computational thing that you have to do. And then what you're actually going to submit are what's called tensorboard.dev web pages. And so in the first welcome video, I talked about how this Google programmer Gal Oshry saw our course and was telling me about this tensorboard.dev product that he works on and how we should use it for our course. And so we're going to, because it is a really cool product. What this does is it's an extension on TensorBoard that now if I click this link, everybody has access to be able to see what my TensorBoard ran looks like. So the original TensorBoard program, only is visible on your own local computer, but with this tensorboard.dev, it's visible everywhere. And so what you're going to submit are the tensorboard.dev web pages that show me that you've done these two training runs that we were just talking about. Yeah, so if we go back over here, this is roughly what your submission web pages should look like. They'll have 3 different training runs, each with different learning rates as you do the step learning rate decay. And then I can just look at it and see what is your accuracy, what are your loss values. Yeah, so how do we use this tensorboard.dev? Well, there's a web page called, conveniently, tensorboard.dev, like this. And you notice that this is preview technology, so we are, I had not heard of this at all before Gal Oshry. He saw our course webpage and it's given us the heads up. There's pretty good instructions on this tensorboard.dev web page. So again, the URL is just tensorboard.dev. Type that into Firefox or Chrome and it'll take you here. And then the instructions for how to use this are, first you have to install the latest version of TensorBoard. So make sure that you run this command right here to get the latest version or it won't work. And then all you have to do is add, right after your call to TensorBoard, add this dev space upload command, and that'll make it so that the web page that gets generated is on the gets published onto the internet, and you get a URL out that anybody can look at. So that's all you have to do. And then you put in the logdir logs just like normal. If you want, optional, you can name your experiment and provide it a description, but I didn't do that. It's not required. And that's all you have to do for tensorboard.dev. Just add these extra lines. So it's pretty easy. I thought it was pretty cool when Gal showed me that. Okay. So that's all you have to do for the assignment itself. Again, all the code I'm giving you, all the Python code I'm giving you in the videos, and I want to do this so that, because again, I realize this is a time of big transition for everybody, and probably a lot of you are super stressed out, so I want this homework assignment to hopefully not be stressful for you. That if you just watch the videos, follow along step by step exactly like I do, then everything will work. If, however, you do want to try to stretch yourself a little bit, which I totally recommend, I have these optional tasks like normal, and so let me describe what they are. So the first one is this modify the CNN model class so that it predicts the next character. That when I was in the videos, we were making all this code, notice that I only edited the RNN model class and I did not modify the CNN model class. Well, CNNs can also predict characters just as well as RNNs can, and so this first task is to actually do that. The code is essentially just taking the code that we did for the RNN network and putting it in the CNN network. So there shouldn't be anything super tricky here. Oh yeah, so I also talked in one of the videos about something called rejection sampling as an inefficient way to generate samples from a certain nationality. It's very easy to implement, and so I'd recommend trying to implement that yourself. A little bit more complicated to implement is this beam search algorithm. It's not too bad, roughly on the complexity of like a balanced binary search tree, maybe even easier than that. But yeah, so again, if this was like the normal portion of the course, I would have made this a part of the requirements of things that you have to implement. But for this portion of the course, or because of all the weirdness, this is an optional thing for you to do. It would be good to do though, because when we do the future assignments, say like when we're working with this coronavirus news data, having a much better sampler than the greedy sampler will give you much better results down the line. Yeah, and then so for your actual submission, all you need to do is submit your links to the tensorboard.dev web pages. I don't need any of your code because sort of I already have your code. Yeah, if you have any questions about the assignment or about anything else in the class, feel free to either post an issue if you think it can be handled that way over text, or if you want to schedule a time for me on Zoom. I'll be posting regular office hours on up here that you can drop into, or we can arrange something special over email. If you are in a weird time zone, or your time zone's not weird, your time zone is probably in perfectly normal time zone. It's just a very different from Claremont time zone. If you're in that situation in a different time zone, I'm happy to work around your schedule and schedule something either very late in the evening or earlier in the morning here Claremont time, so that it's not 2 a.m. For you that we'd be meeting. Okay, well, I will see you all on Zoom and on GitHub.